2D viewing transformation, that is window to viewport transformation. Here in the 2D viewing transformation, we map a part of the world coordinate scene to device coordinate. And here you can see that, let us suppose there is a world view in a 3D form, and we have to capture, or we have to take this part of this 3D world by using this rectangle. And as we capture this image, so by using the projection, basically this 3D image is transferred into an viewing plane, that is a 2D viewing plane, and this image is formed. Now we put this image into an viewing port, and after that, that very viewing port needs to be displayed on different display devices. As we know that different display devices or monitor or screens have different sizes, so we have to adjust that image according to their size. So it requires scaling, because we have to keep in mind that we have to preserve the correspondent ratio or the dimensions of the image. So the only way we can reduce or increase the size of image is by using the scaling graphic transformation. So 2D viewing transformation is the process of translating 2D world coordinate object to device coordinate, and this process involves various graphic transformation. It involves translating, scaling, and maybe rotation, and maybe any other. And combinedly, all of these graphic transformation is called the 2D viewing transformation. Now we will see step by step that what is happening in this whole process. Here you can see that this is our world coordinate system, and this is our device coordinate system. Inside this world coordinate system, let's suppose this is a world view, and we have to capture this much image. So we use the window. Anything that come under this window is captured and formed into an 2D image. Now that image is put into an viewport, and here you can see that we have scaled this image, we have reduced its size. Then this viewport, it is adjusted according to the device coordinates. And here one important thing to notice is that, let us suppose if this is the window, and we can say that here this vertex, this vertex, and this vertex, and this vertex, there are the four vertices, and this having the x w of minimum, that is x, that means the x minimum of this window and x maximum of this window. And here you can see that if we talk about the coordinates of these vertices, it will be the x minimum of this window, and this will be the x maximum of this window. So we will write it like x w max. And if we talk about the y coordinates, this will be the y minimum of this window, because there is no other coordinate below this, and this will be the y maximum of this window. And if we retrieve the coordinate values of this point, so it will be the x maximum of this window. Here the x coordinate will be same as the x coordinate here, and so we will write it x maximum of this window. And if we talk about the y coordinate, it will be the y maximum of this window. Okay, because y coordinate here and here will be same. Okay, similarly we can give reference to the viewport using the device coordinates. Here you can see that y minimum of the viewport, y x maximum, y minimum of the viewport, and y maximum of the viewport, x minimum of the viewport, and x maximum of the viewport. Okay, and these four vertex are enough to define the rectangle and to define a window or viewport. So let's proceed further. Here you can see that first of all, in the first step, what we will do, taking a window and capturing an image of this 3D world view. Then this image is put into an viewport, and that viewport is adjusted according to the device coordinates. Here you can see that this image is smaller and this image is a little bit bigger. But if you look at all of these three images, you can see that images are same. The only difference is the difference in their size. So the best way to perform this graphic operation is to perform it through scaling, because all of their respective dimensions size increase or decrease in a fixed ratio. This rectangle we called it window, and this is our viewport that is being placed in an mobile screen. And here the viewport is exactly fixed in the LCD display. Now let us suppose we have to map this rectangle to this viewport. So how we will do that? Mm, as we know that we have to perform the scaling here. So if anything that is just in the center of this rectangle will also be in the center of this rectangle. Fine. So that means that we have to look at the ratio and we have to look at the factor through which factor this image is getting reduced or increased. Let us suppose if there is here is the rear mirror of this truck, and what will be the exact position of this rear mirror in this viewport? It will be here, but let's now measure this. So what we are going to do, we are going to see the x coordinate of this mirror inside this rectangle window, and we are going to see that how large is this window. Fine. And then we will see the same thing, we will see that how far is the x coordinate inside the viewport, and how long is this viewport in the x direction. We are only talking about the x directions right now. And let us suppose we say its distance from this point to this mirror is d0 in the x direction, and the distance in the viewport is d1, and the total length of this rectangle is L0, and the total length of this viewport is L1. As we know that their ratio will be the same, so we can say that D0 by L0, that is this length divided by this length, will be exactly same as this length, that is D1 by L1. Let us suppose if DL let us suppose if L0 is the length of the rectangle and L1 is the length of viewport. So we can say that if we have decreased this L0 length with certain factor, with the same factor we have to reduce this distance as well. So this is the only way to perfectly match or to perfectly map an image in the rectangle to the viewport. And same can be applied for the y coordinates as well. We have to see how far this mirror is in the y direction, and how long it is uh, how long is the height of the rectangle window, and the same we have to see that how long the height of the viewport and how far this mirror is in the y direction. So there are some terms that are included in the 2D viewing transformation, that is world coordinate. We know that it is the Cartesian coordinate with respect to which we define the diagram. Like here, that is x of minimum of the window, and x coordinate of the window, maximum x coordinate of the window and minimum x coordinate of the window, and maximum y coordinate of the window and minimum y coordinate of the window. Same is here. What are the device coordinate? It is the screen coordinate where the objects are to be displayed, like the uh, mm, like the x maximum of the viewport and x minimum of the viewport, y maximum of the viewport, y minimum of the viewport. And what is the window? Window is this rectangle. Okay, it is an area on the world coordinate that selects for the display. And what is an viewport? It is the area on the device coordinate where the graphics is to be displayed. So this is not actually the area of the device, because we know that here you can see that this is whole of our device, but viewport is just this much area. So we have to place this viewport inside the device. Now we will look at the derivation for any arbitrary point that is here in the world view, and how that very point can be mapped in the viewport, and we will drive the equation for that.